Section 2.2, algebra functions. So you're going to perform basic operations on functions, adding, subtracting, multiplying, dividing. So if f and g are functions and x is the domain of each function, then f plus g of x is just simply f of x plus g of x. F minus g of x is just f of x minus g of x, and so on and so forth. F times g of x is f of x times g of x, and f over g of x is f of x over g of x. Provided g of x doesn't equal 0. You cannot have 0 in the denominator. We're going to talk a lot about domain in this section. Okay, so the very first problem we're going to go through here on this one is that you have f of x equals x squared minus 3 and g of x equals 2x plus 3. Find each of the following if it exists. Well, they're asking you to find f times g of 2. Now you have two choices here. You can multiply these two together and then plug in 2, or plug in 2 separately and then multiply the two together. We're going to do the latter. So we have f of x, which is x squared minus 3, times g of x, which is 2x plus 1. But we know that x equals 2. So we're going to plug in 2 everywhere we have x. So we have 2 squared minus 3 times 2 times 2 plus 1, which gives us a 4 minus 3 times 4 plus 1, which gives us 1 times 5, or simply 5. Okay, yeah, I went through it fast, but this is just a straight out plug and chug type of problem. So now the other way would have been to FOIL this out and then plug 2 in at the end. Let's not make life difficult on ourselves. Plug in the known values and then go. Okay, so let's try another one. We have x squared, well, it's the same one, x squared minus 3 and 2x plus 1, but I want g over f at negative 1/2. So let's write it out, g over f. 2x plus 1 over x squared minus 3. But again, we know x equals negative 1/2. So we plug it in. 2 times negative 1/2 plus 1 over negative 1/2 squared minus 3. This gives us a negative 1 plus 1. Okay, I'm not liking that. So let's try it again. Negative 1 plus 1 over 1/4 minus 3. And 1 minus 1, 0. And 0 over anything that's not 0, so 1/4 minus 3, is just 0. 0 in the numerator is 0, 0 in the denominator is undefined. Okay, again, this is really the only way you should approach this one here. You couldn't have done anything beyond that. Okay, so these are the beginning of the problems, not too terribly bad, but, and you should be able to work through most of those. Might have questions on some of them, but you should be able to work on most of them. Okay, so let's review domains. Linear function, your domain is all real numbers, or negative infinity to positive infinity. Now I'm going to let you know that for the most part I want these in interval notation, and this is interval notation. A lot before this you've done set notation, all values of x as long as x is a real number kind of thing. We're just going to go through this. Quadratic functions, no restrictions. There's no restriction on what value of x you can use. So all real numbers, or again, negative infinity to positive infinity. Then we have our square roots. A square root cannot be a negative under the radical. So we need what's under the radical to be, so 2 minus x, to be greater than or equal to 0. It cannot be less than 0 because that makes it a negative number. So I'm going to go ahead and move that 2 over, so I have negative x is greater than or equal to negative 2 divide by the -1, and hopefully you remember when you divide by a negative number with the inequality, this guy changes directions. So x has to be less than or equal to +2. And we can always test it. You put in 2, 2 minus 2 is 0. Okay, it's good. And it says that x must be less than 2, so let's use an easy number, 0. If I put 0 here, I get 2 minus 0, or 2. So this looks good. Now if I put in 3, I would have 2 minus 3, which is -1. -1 can't have a square root of a negative number. You know, you guys can't say, well, this is 1 times -1. It's a perfect square, though, so it has to be both negative or both positive, not one of it each. Okay, rational functions, they have restrictions too, and it's the denominator. Your denominator cannot equal 0, so you just simply go, oh, well, x plus 4 cannot equal 0. So that means x cannot equal -4. And then your absolute value functions, this one has no restriction as it's set up. Only thing absolute value tells us is the y value has to be positive. What's in there can be anything we want. So this one, the same as before, all real numbers, or -infinity to +infinity. Now the only other ones that we really need to talk about is like your cube roots. Cube root also is all real numbers because cube root of 8, 2, cube root of -8, -2. So that's one to talk about. And then the other one would be logarithms, and we'll talk about logarithms when we get there. Okay, this one here I will have out for you guys. If I don't have it to you by the time you do these notes, remind me of them, but I do have quite a few. I think I may have given these to you guys before, but I should have quite a few of these copied still. Trying to figure out the domain for a function, worst case scenario, and you start, do you have a fraction? Yes or no? If the answer is yes, like in our last problem where we had 3 over x plus 4, do you have a radical in the denominator? Yes or no? Well, in that particular problem, the 3 over x plus 4, it would have been no. Set your denominator equal to 0 and solve. This gives you a restricted value, so your domain is all real numbers except for the restricted value. And so in that last one, you would have done the x plus 4 equals 0, solve, and you go, oh, all real numbers except. I should go back and put that with an interval notation. I don't think I did. If you have a radical in the denominator, it can't be 0, so then you're going to just set it greater than 0. Now, these ones here are for even roots. You know, square root, 4th root, 6th root. Anytime I talk about a radical, I am talking about even roots. Because again, a cube root, it can be negative. It's okay. Do you have a radical? So this would be kind of like the square roots one. Set your radicand, that's what's under the radical, greater than or equal to 0, and solve. That is your domain. The only time you won't get your domain off of this is here. And it's all real numbers except for whatever value you get. Otherwise, with what we're doing, it's all real numbers. Do not let the domain throw you off. Keep in mind, these are your x values. We'll talk about this again tomorrow in class. That way, if you have any questions, and then you can write some more notes on your papers, whatever. Okay. So now, on the next couple of problems, on your paper, first of all, I'm going to throw this out there. On your notes, you will realize that I have a blank. I have all the problem and then blank. It's because I just made a blank slide. That way you have room to continue writing this one in. Otherwise, it would just make one skinny file there, and it's just easier for you to write this way. So part A we'll do on the one page, and then part B you do on the second side. I'm going to do all of mine on the one because I don't want to go back and forth from one page to another on you guys. So domains, if f and g are functions, then the domain of the function f plus g, f minus g, and f times g is the intersection I saw that. Okay. I can't move it down. It won't move for me. Is the intersection of the domain of f and the domain of g. The domain of f over g is also the intersection of the domains of f and g, with the exclusion of any x values for which g of x equals 0. We'll see this one. I know I have one of those, and we'll probably play with that one in class. Okay, so find the domain of these two guys. So the domain of f, since I have no fraction, we can go back to your domain flowchart. Do you have a fraction? No. Do you have a radical? We're looking only at f of x. No. So the domain is all real numbers. So negative infinity to positive infinity. And g, do I have a fraction? No. Do I have a radical? Yes, I do. So you're going to take your radicand and make it greater than or equal to 0 and solve, which will give you x is greater than or equal to 1. So bracket 1 to infinity. The brackets, and this was in section 8.1, the bracket identifies that the number is included, parentheses identifies a number that is not included. I can have 1. 1 minus 1, 0. Square root of 0, 0. Greater than 1, so put in 2. 2 minus 1, 1. Square root of 1, 1. Hey, I'm good. Now, from this point on, we look at f plus g, f minus g, and f times g. They said they're going to all be the same. And it's going to simply be the intersection of the two. Now, let's draw out a number line. So I have a number line. This over here is infinity. This over here is negative infinity. And let's throw in 0 right here. Let's throw in 1. Let's throw in negative 1. That, we get a little perspective here. This guy here is all real numbers. So I'm going to grab a highlighter. And I'm going to draw all real numbers. From negative infinity to positive infinity. The other guy is only 1 to infinity. So he's here. So the intersection of the two is where they both have the same color, which is G. So the domain on these three here is 1 to infinity. Okay, and then we have f times f. Well, that's just the domain of f, which is negative infinity to infinity. And then we have f over g, which is going to be negative infinity or positive infinity over 1 to infinity. Well, it's this guy here, except for now I can't use the 1. So he turns into a parentheses. So my domain for this guy is 1 to infinity. We still have our picture over here, 1 to all of infinity and 1 to infinity. Only this time, 1 will give me 0 in the denominator, and we're not allowed to have that. So we take the bracket off and make it parentheses. And the last one, g over f. Just flip this guy over, but it's okay to have 1 in the denominator, or 0 in the numerator, sorry. So this is 1 to infinity over negative infinity to infinity, which is going to give us the bracket of 1 to infinity. Oh, but let's look at this guy for a second. Shame on me for not catching this. This guy is x plus 2 now. And x plus 2 cannot equal 0. So that means x cannot equal negative 2. Whew, we're okay, because negative 2 is not there. Forgot my s. Is not there. So we're okay, because negative 2 is not here anyway, so it doesn't matter. So there's all of our domains. Now the second part where they want you to find f of x plus g of x, f minus, and so on and so forth, those are fairly easy too, unless you have fractions or something. So let's go ahead and do that part. So let's remind ourselves, so I don't have to go back and forth with this. F of x is x plus 2, g of x is the square root of x minus 1. So on f of x, so f of x plus g of x equals x plus 2 plus the square root of x minus 1. F of x minus g of x is x plus 2 minus the square root of x minus 1. F of x times g of x is just x plus 2, notice I put these guys in parentheses now, times the square root of x minus 1. Really no sense in doing anything beyond this one. I mean, if you want to, you can, but it's just going to be x times this plus 2 times this. It's just as simple to leave that. Next one is f of x times f of x, or f of x squared, which is going to give us x plus 2 squared. Or for those of you who go, I wanted to write it the other way. And if we FOILed it out completely, we get x squared plus 4x plus 4. Then we have f of x over g of x, which is x plus 2 over the square root of x minus 1. No, you don't have to clean up the radical. I'm not going to be that picky on you. And then we have g of x over f of x, which is going to be the square root of x minus 1 over x plus 2. I should point out, hopefully you saw this, is that these two are just going to be reciprocals of each other. And these two is just a change of sign. Nothing more. Okay, so next problem. I just blanked that one out. We have f of x is 2x squared and g of x is 2 over x minus 5. Now this one I'm going to throw out there to you guys. We are going to, at this point, we're going to do part A, but part B we're going to do in class. So I am going to throw that out there. I have that on my notes that part B we're going to do in class. Okay, but look, part A we can do the domain part. So I need the domain of f. No fraction, no radical, all real numbers. And G, I have a fraction, so I take x minus 5 and set it equal to 0. So that gives me x equals 5. Remember your domain, all real numbers except for whatever you get here. So negative infinity to 5, and union that with 5 to infinity. Now, I'm going to be really, really bad at this point because I remember just now on that one domain sheet that I did not fix it. So I am going to quickly go back to our domain page, which isn't that far, and rewrite this one particular one. Here it is. Remember, it's all real numbers except x cannot equal negative 4. So it's negative 4. It's negative 4. That's wrong. That's what I get for having an alarm go off on me in the middle of this. Let's try that one again. It is negative infinity to negative 4. Union that with negative 4 to infinity. Basically, all I said, it's all real numbers except for right there. The parentheses identify the fact that we are not using 4. Okay, so let's go back to this one. F is all real numbers, G is everything but 5. So F of x, So it's f plus g. I'm not going to get real specific writing that out. F plus g, f minus g, and f times g are all going to be the same. And I can do that number line again. Negative infinities here, positive infinities here. I'm going to put 0 here, 5 here, -1 here, get some perspective going on. Grab my highlighter, all real numbers, which means everything. And then the other one is 5, everything but 5. So I'm going to go all of these values to here, and then I'm going to jump over 5 and keep going. And so the intersection you can see is everything except for right there at 5. So really we're taking the domain of G. And yes, that's how you can look at it. We're taking the domain, you take the smaller of the two. So my domain for these three, -infinity to 5, union that 5 to infinity. Okay, f times f. We just take f, so -infinity to infinity. F over g. I look at both of these, and it's the same as this one here. 5 is going to give me 0, and I don't want that. So we put it in there as the same as this one here. You can look the same here. It's going to be -infinity to infinity over -infinity to 5, union with 5 to infinity. And you quickly see 5 will give me 0 in the denominator, so I can't have it. So my domain, -infinity to 5, union with 5 to infinity. G over f, however, has a little bit of something going on here, because we have g, -infinity to 5, union with 5 to infinity, but f is going to change, because if I put this guy in the denominator, x cannot be 0. So he's really going to be -infinity to 0, union with 0 to infinity. So I can even write this in there. That's 2x squared in the denominator. 2x squared cannot equal 0. Therefore, x cannot equal 0. So my domain on this guy, we got 2 breakups. So I'm going to bring this guy down here a little bit so I have room to write. It is going to be -infinity to 0, union that with 0 to 5, union that with 5 to infinity. Okay, so this is probably the only one that we might need to talk about tomorrow in class, but we do need to go through that one. Okay, sorry about that. Now I did put a little X here to show that, oh, that should have been at 0. Let me undo that. Put a little X here at 0 to show that once I put f in the denominator, 0 became a bad spot. So you can see that that's not a good spot, 5 still not a good spot, and there we go. Okay, so the next one here I have down to go over in class, I believe. Again, I'm going to go ahead and do the domain on here. We can actually, this one here, I'm going to let the whole thing for tomorrow. We'll go over in class, because we have one more behind this one, which is one of the easier ones to do. So this, here it is, f of x is 4 absolute value of x, and g of x is 1 minus x. Absolute value doesn't say anything about domain, it's all about the range. So f, the domain is all real numbers. G, no fraction, no radical, all real numbers. That's why I say this one is a lot easier. So when I get to f plus g, f minus g, and f times g. They're all going to be the same, but it doesn't matter. Negative infinity to infinity, because there's no restriction on either one. And then when I do f times f, again, no restrictions, negative infinity to infinity. F over g, well, we have a little restriction now because you got f over g. No restriction in the numerator. But if we look at g, 1 minus x cannot equal 0, so 1 cannot equal x. So this one here, I mean, we can start it off as negative infinity to infinity, and then identify that x cannot equal 1. So it's really negative infinity to 1, union that with 1 to infinity. And then g over f goes back to negative infinity to infinity. And this one is negative infinity to infinity, but if we look at f, x cannot equal 0. So it's negative infinity to 0, union that with 0 to infinity. Okay, again, the last problem, we're going to play with that one for domain and range. Maybe, hopefully, by then you guys will go, oh, okay, I've got this domain range thing down. Okay, the rest of it asks you to do the f plus g, f minus g, and so forth. And these are fairly simple ones. So let me remind you, f of x is 4 times the absolute value of x, and g of x equals 1 minus x. So if I do f plus g, then it's going to be 4 absolute value of x plus 1 minus x. There's nothing else I can do to this guy, honestly. In all honesty, nothing else we can do. Because this guy has to be positive, this one does not. F minus g, the only thing you have to be careful here is 4 absolute value of x minus the quantity of 1 minus x. So what we have to do is distribute that negative through. So you have 4 absolute value of x plus x minus 1. We still cannot combine these two because he has to be positive. He still does not. So if x was negative 3, that's okay, that would be 3, but this would be a negative 3. Okay, the next one is f times g. So now we have 4 times the absolute value of x times 1 minus x. I probably would just leave that one alone right there. F times f is going to be 4 absolute value of x squared, which is going to give us 16x squared. Guess what? As soon as we square that thing, we guaranteed x is going to be positive. So it doesn't matter now. If x is negative 2, negative 2 squared is 4. It doesn't matter. It's the square is guaranteeing the square now, or the positive number. F over g is going to be 4 absolute value of x over 1 minus x. Nothing more to it. And g over f, 1 minus x over 4 absolute value of x. Again, can't do anything more to those than that. Okay, so yeah, this is it. There's a few that we're going to have to play with tomorrow in class, but we will. Otherwise, you've got the homework. It's on the back of your notes. Go ahead and start working on some of those. And good luck. Talk tomorrow.